Всем привет.
Hi, everyone.
Начну
Look, I'll start
рассказа о себе.
traditionally with a short introduction. I've been doing database development for more than 20 years. I've worked in different well-known companies.
Кодом
I was mostly doing my SQL code or some derivatives. For instance, in Huawei, I was working on creating the cloud version of MySQL. But not only that, I've also worked with other database code. And whichever databases I was working with, I was coming back to MySQL. So at the end of last year, my colleagues and I founded a company called MyDB. MyDB is a Russian competence center in the MySQL ecosystem. The product is open source. It's based on the MyDB server, and it's MySQL with some extended capabilities. We've worked for many years on the server. I used to be lead developer in this project, and the focus of our today's development is in three things. Firstly, performance, second, monitoring, and third, usability. Nothing new here. Our parent problem, Percure server, in the parent project, the priorities were the same, performance, usability, and monitoring. But just because these are perennial things, it never happens that the user complains that the database performance is too high or that monitoring, there are too many monitoring tools. Well, on the other hand, there are always use cases where when these features are in shortage. The list of companies that are using our developments keep growing. We support development and training not only for MySQL, but for all products from the MySQL system, including MyDB, having huge experience. So what is this presentation about? It's about database performance, but at a different perspective. In all those years that I've been taking part in database development, I've been talking to database users, and I've noticed that there are certain aspects that keep in shadows. People overlook them, discuss them perhaps too rarely, know too little about them, or have myths about them. As a rule, these are small questions about which you can't, run a separate presentation about each of them. And it's perhaps the reason why they are kept in shadows. Or the other way around, there's so much hype about some questions that for users, it's difficult to put the handle on these aspects. And quite often, it turns out to discuss them much more effectively. It appears to bring all these questions into one presentation and discuss them as a whole. The users I was talking about are the users on Postgres and MySQL. To structure my presentation, I split it into several groups, aspects relating to the operating system, to the database, and data storage architecture. So I'll be moving along in this order that is shown in the picture. Let's start with setting up the operating system, the simplest thing that you can do. But in fact, a lot of users either don't know or undervalue the operating system settings. There are quite a lot of effects here. I've just mentioned the top three things in each group. But of course, one needs to make a special presentation to talk about that in detail. I'm not going to get into these details, and I'll explain why a little bit later. But on the whole, from the CPU point of view, the most frequent errors people make is that energy saving is not set up correctly. For instance, it's enabled turbo boost is enabled, and these things affect not even the absolute performance, but the stability of performance. For instance, you quite often see that the
данных, и процессору нужно больше времени, чтобы проснуться из какого-то
energy saving is enabled while the load on the database is low, and this all brings about hard predictable spikes.
знаете, они обеспечивают
Turbo modes provide good performance in spikes, but affect negatively the stability of the system operation. If you talk to people who service high-load systems and databases and ask them what characteristics of the database is most important for them, they'll say stability, not even the peak performance, but stability. We need all these graphs to be flat. And from this perspective, you also have to understand about it. And in terms of memory, there are lots of fine things related to numerical memory architecture, swappiness. The schedule has a lot of settings. I've only given 3 here. In fact, there are dozens of them. And they all can affect the performance, sometimes changing performance by the factor of 10. And about 10 years ago, I was making whole presentations and conferences how to set up the operating system correctly for the database, for instance, for production or for testing. So as to run comparative analysis. But that's what I was doing about 10 years ago. What's happening now? Now the life has become much easier. Firstly, the default settings in DB Linux and other operating systems have become much better for modern systems, for high loads. But it's clear that these default settings are not always keeping up with the development of workloads. But nevertheless, the situation has become much better now than it used to be 10 years ago. But the most important point is that today, what helps us a lot is a piece of software called TuneDemon. It is available for all the OS distributions. It's an attempt to declaratively describe the setting of the operating system. It already has some building blocks that are reusable with the continuity, with the nesting, with inheritance, and it can be done in different ways. All the high-load systems work in specific conditions. In any hardware situation, you have some differences in how the system needs to be set up. And all these periodic reboot things, all this black magic that I used to talk about, that you need to add something to this file and you need to configure things like that. So TuneD automates them a lot, and it makes it very simple. So this example, I have 2 lines of code. Let's say I want a profile that fits the user very well. Actually, it'll match MySQL as well, and I want my settings to provide for the internal for the low network latency. And these 2 lines basically replace 80% of the content of the presentations I was making 10 years ago. So there are some problems left, but it's about really fine-tuning. So one important thing that, so those of you who don't know that, please use. I'd like to speak a bit in more detail about large memory pages, because it's about something that TuneD doesn't support. The database can support huge pages, firstly for the code of the server, and they can be used for data. And in our tests, we get up to 30% improvement in performance, and for dynamic memories for the heap. And any database allocated different memory buffers. They can be quite large. For instance, for data sorting, I don't know of a single database that uses huge memory pages of such buffers, and we're going to experiment there and see what turns up. But in spite of all these good numbers, such a plus 10%, plus 30%, there are companies who are prepared to kill for 5% of performance gain. but if you have 30% of improvement across your server fleet, that would be a reason for publication. But in reality, these numbers are rarely achieved, and the reason for that is the configuration of the operating system, so that you have to reserve these huge pages beforehand, and this is hard to do. So you need to understand how much memory you need. You need to configure it. If you have Docker, you need to write down the references to Docker. So it's very hard to do to achieve these numbers. The tools that provide for these support are not perfect yet, and the support is not perfect either. Briefly, a brief reminder, if somebody has forgotten what it is and why you need that. In most operating systems, you use virtual memory. So each CPU, each process, has its own virtual memory space. This is good for quite a number of reasons. But in order to find a place where the data lies in memory, you need to translate these virtual addresses into physical addresses. And this is done via some tables through the joint work of the CPU and the kernel of the operating system. They run a hierarchical structure, which is not important here. What's important is that each record actually entails lookups in all these tables. The problem is that a standard page in x86-64 architecture is just 4 kilobytes. That was determined historically in the last century. At that time, it appeared normal, but now the typical size of memory in servers measures in hundreds of megabytes, which means that if you have a 4 kilobyte page, you get 10 million such page tables. And if the server is large, you have a memory of a terabyte or several terabytes, then the number of pages get really huge. So it's hard to change this setting because of compatibility or interoperability. I've seen attempts to change it, but it always led to a huge number of problems across the software stack. And it's good that you can send some patch to the Linux kernel to see, but there are also proprietary products that have this page size of 4K hard-coded, and this is one of the problems that Linux kernel developers have to deal with. Another peculiarity of this whole thing is that page tables are copied in the case of every fork, because processes inherit from the parent processes, and you have to modify the settings. One of the solutions to processes instead of threads, and there's this Postgres peculiarity that people talk about, but a little bit too rarely and too little. So Postgres uses processes instead of threads, and that reflects negatively on the processes, especially for systems with quite large cache, with quite large memory, and systems with a lot of connections. You've probably heard that in Postgres, to create a connection, it's a painful and expensive thing. That's exactly for this reason. That's why MySQL maintains a large number of connections. And that's the explanation. I have known these facts all my life, but I decided to collect the numbers, how it looks in numbers. And actually, it quite strikes me. If you take a 180 gigabyte buffer pool, 80 connections, the size of memory spent on these page tables in MySQL doesn't depend on the number of connections, and will be some up to 270 kilobytes, less than 1 megabyte. And the size of the same pages in Postgres will be 25 gigabytes. So for a 192 gigabyte memory server, or 128 gigabytes will be the buffer pool, and the rest will be for page tables. And that's the memory that could have been used for cache or for other things to improve performance. So it's quite a serious architectural limitation of Postgres. And quite often in mailing lists of Postgres developers, you hear suggestions that one needs to change that, and every time the response is that it will take a lot of effort. So everybody agrees that it's a bad architectural decision, but also people say that it's too difficult to fix. So how to change this problem? How to solve this problem? The problem of non-using huge tables for data. For the core, the story is different. You can actually run this perf command, and if you see more than 1% in this path, then it's like in that saying, in that meme, Houston will have a problem. So what you can do, you can reserve your memory for huge pages beforehand. That's very inconvenient. It's not covered by TUND, but you can, assess it somehow, calculate everything, set Postgres up for the use of huge pages, and be happy with a boost in performance of up to 30%. Of course, if you have to reserve something, you'll get a smaller boost. But yes, such a simple thing, a relatively simple thing that can be used. In our tests, MySQL gets some funny numbers, but it's just because it's good about this. It doesn't have the problem that Postgres has with huge pages. There's also a thing called transparent huge pages. Basically, it was designed to solve the problem with the reservation of large pages. So the kernel moves small pages to huge ones, but there are drawbacks here. The CPU usage, utilization, and memory and background activities lead to the slowing down of applications. So basically, all database vendors disable this feature. Because maybe for for other programs it may work correctly, but for databases it entails a lot of problems. Operating system updating. It's not talked about a lot in the context of database design, but actually it can affect performance in quite an unexpected way. So problems with any database can happen in respect to database to operating system update. And for many years, it's been known that with Postgres, the order of sorting has been affecting that. That this is a case encountered in February this year. It turned out that in the new GMC version, the developers overlooked a problem that affected Postgres, and then operating system developers decided to ignore. And so Postgres users found themselves in a difficult situation. So whether the system is Red Hat compatible or not. In MySQL, they did the right thing. Initially, they decided not to depend on any systems libraries and implemented their own library. And so over the 20 years of the history, I can recall maybe two big problems caused by this solution, where indeed something was broken, something with the coding, and it led to problems. But in Postgres, this keeps happening all the time. Now let's go to the database setups. Here I can say that Postgres deserves commendation. It's better set up out of the box. And there are two parameters that needs to be improved: the shared buffers, the size of the database cache, and for some unknown reason, in 2025, the checksum for data are disabled by default. It's another thing that you can't explain, just like in that joke about the language of Russian in a Georgian school. So, children, you can't understand this, but you have to memorize this. So you have to enable it manually. But nevertheless, of course, there are some other parameters that you need to tweak. For instance, if you have load with intuitive recording, some other parameters, but on the large, this is the full list of parameters that in most cases you need to tune. In the MySQL case, it's so much more difficult. It's more difficult to set it up out of the box. There's a list of parameters that need to be improved for maximum performance, which is too difficult for most users and even administrators. When we had a joint presentation for the previous high load together with Alexei Rybakov, we had to compare performance of Postgres and MySQL on a very specific workload. And the purpose of the presentation was to decide whether relational databases could be used with caches. Because cache implied very simple read requests. Alexei, many of you know him, he has a lot of experience working with back-end development. And when we were setting up the systems, when he just started testing it all, the system showed low performance. He turned to me, I took a look, and I decided yes. So as a result, we set up MySQL so that it should show good results, even a little bit better than Postgres. But I thought that something needs to be done about that, because even the person like Alexei can't fix that themselves. It's clear that one has to simplify these things. You can't say that nothing at all is being done there. MySQL is getting better and better. More than that, they often become such that the number of threads is not hard-coded by default, but it changes dynamically depending on the number of available cores in the system. So there are steps towards auto-setup in case those values are not specified explicitly. So in the recent version, for instance, you got this exciting option that adjusts the cache size depending on the size of the available memory. It's also a very good thing. But it's all yet available for NDA parameters, and the option as such is disabled, so you need to enable it. So we at MyDB have already done some wrapper around this. It's enabled by default, and it's installed, so enables the reasonable value for the parameters. So the goal is to make sure that my SQL shows good performance in 80 cases, in 80% of all cases. And there are some work to be done in the future. And we're planning to keep developing in the following. Firstly, to include auto setup for a specific workload. It's not a simple thing to do, but we have this task of setting up for a pool of connections based on serious mathematics. And there are some non-trivial methods being used. So it's a task that's complicated, it's a problem that's complicated not only at the engineering level, but also mathematically. And then you want to make all these default values container aware. So that would be a big step. Because even now, it looks at all the available resources in the machine, but now most machines have different containers. It would be right to take a look at the resource of the container. So far, it hasn't been implemented, but we're planning to do so. And the next phase, that under dynamic changes, that in the case of dynamic changes in the containers, we also plan to make that automatic setup container aware. Another thing is asynchronous I/O and direct I/O. So what I'm talking about, modern drives and databases can show fantastic performance, millions of IOPS. So in order to saturate that, I mean, the application, it's not a simple thing for it to get to the saturation, the other way around. So in order to use such systems effectively, the ones that have quite high performance throughput, but at the same time low latency, a high latency, one needs to think about making the I/O work better. I've been working on that for quite a long time, and there's room for improvement there. In Postgres, this thing will only appear in the next release. It's been expected any moment. And the appearance of this async I/O in Postgres is quite a new thing. I've been keeping an eye on how it's done. I've been keeping an eye on this project for quite closely, but so far what's going to be released in the next version of Postgres has serious limitations. There's no direct I/O. It'll only work for reads and only for certain types of access to the tables. Nevertheless, if you believe that your database, your Postgres, has a problem with the disk system and async I/O could help it, you can take a look at the next version of Postgres and the settings that it will have. Now, connection pools, quite a typical thing that users bring up. MySQL doesn't. MySQL maintains thousands of connections without a pool. In Postgres, the situation is quite sad. The need for using pools in Postgres emerges much earlier. It maintains hundreds connections without a pool rather than thousands in the case of MySQL. And what you should just say. So I will just add PG bounds and that's it. Or some other products. But it is strange that none of these products have a complete set of functionality. And so here, I need to explain certain things that are obvious to me. Any external connection pool has its own problems. Firstly, it becomes clear immediately once you start familiarizing with them. There are different settings, none of which different modes in which they operate. None of them is optimal. I have heard a lot of presentations where people would discover that there's no complete transparency of applications. So everything used to work okay for the testing environment. And then in production, everything was starting to deteriorate because people had not read the documentation. There are lots of subtleties, and it's all because this functionality is implemented outside the database. There's a certain state in any connection. Firstly, open introduction, prepare statements. There are session parameters. And if the pool is implemented within the database, just like in MySQL, there's no problem understanding which connection has which state. And if it's all implemented outside, you need to somehow make sure that the connection switching between the input and output connections is done in a proper way, so that this connection state is passed correctly. So it's a non-trivial task that requires a lot of resources. So in any event, an external proxy will need to take two system calls. It'll first need to read and then send to the database. So we ran our own tests. My colleagues ran them. They were using different proxies for Postgres, and they all increase the latency time by the factor of 2 to 4 PG bounces twice, another one 4 times. The best example, there's a proxy in the MySQL world, but recently they added Postgres support, and in our test is showing the best results, the least overhead being added to the system. Schema optimization. Well, I would like to avoid, trivialities. Everybody knows that indexes are good, but excessive use of indexes is bad. I wouldn't like to talk about that today. I would like to share something, more up to date. The problem that's not so wide known among users, it's about alignment. So if you create a table, A and B, true, false, MySQL or InnoDB will store it in the disk in about the same this form. Firstly, you have a 0. In this presentation, it means true. Then you have 2, and then you have zeros. No surprises here. And I omit a lot of subtleties, service fields, and other things. But in Postgres, it's almost the same. But between 1 and 2, there are quite a lot of zeros. What's that? This is about alignment. These 7 zeros are basically adding zeros so that the value of 2 should be aligned in terms of being recorded. So the offset of each field in the record is done through adding zeros. It's not a very good architectural decision. I have some ideas why people did that, but I don't think those reasons were important enough. It can all be bypassed. And the good example of that is MyDB, because they were able to bypass these restrictions. And so I ran a bit of a comparison. I loaded 10 million lines like this, strings like this. And the difference is about twofold. In MyDB, it occupied about 97 megabytes, and in Postgres, about 600 megabytes. So it's not because only of this alignment rule, but also Postgres uses a lot more space for other things. And worldwide, if we take a look, it's hard for me to imagine how many extra petabytes of zeros are being stored and processed in Postgres systems. So some people don't know about that, and even you know about that. Not always can you affect that. Compression. There are 3 types of data compression in MySQL: table-based, page-based, and column-based. The table-based and page-based compress both data and index. There's another type of compression, column-based. It was developed by Alibaba, and then it was passed to the developers. It compresses certain types of colleagues and keeps the functionality, which is used when you have a column with a lot of repeated words, which happens quite often when you deal with XML data, JSON, and so on. In certain cases, it can also improve performance quite a lot. And in MySQL, there's an even more advanced compression. In Postgres, there are, the limit of the set of compression types is quite limited, and the user doesn't really have capability and opportunity to change those. It all happens behind the scenes automatically. There are alternative storage systems such as columnar, but we're not covering them right now. In terms of request optimization, I wouldn't like, again, to say anything trivial. Well, users know trivial things quite well, and there are a lot of books and papers written about that. I would like to highlight the following points. There's quite a curious thing in MySQL. It's called explain for connection. As far as I know, in Microsoft SQL Server, something like that exists, but it's missing from Postgres. So what's about? You can take a look at the explain for this connection. And unlike it's done in Postgres. So we need to do it right here and now. We need to run the debugging right now, for instance. It's very important that you have this request. It runs for a long time. But and for some reason, so normally it runs very fast. And today, right now, for some reasons, it takes a lot of time. So this is for which this feature is. It appeared quite recently, and not all MySQL users are aware of it. And in Postgres, there's no analog of this. Optimizer trace are also a curious and interesting thing. In actual case, it saves the situation, saves the day. What does it do? It shows, or rather, then showing the execution of the request. It explains why the scheduler has decided to implement this plan. And again, I've talked to developers, and they said, had Postgres had a similar feature, we would be ready to kill anyone, they tell us. Joking, of course. I run an optimizer trace and then see what the Google trace shows. And then it shows the first I ran the scan and then looked at the scan by the index, but the cost turned out to be higher rather than the first case. So that's why the developer has taken this case. Scheduler hints. The idea was that there are no such thing as a perfect scheduler. They all use statistics. You don't always have the right statistics. There's no single database where the scheduler works perfectly. They all make errors. Most databases have these hints. In MySQL, they've existed almost always. There are now 25 types of them, and I'm just showing an example how they look. In Postgres, there are no built-in schedulers as a matter of principle. For some reason, they believe it's a bad thing. So the Postgres community has to have it implemented using some external solutions. The most popular external extension is PG Hint Plan. They don't always keep up with the changes in the Postgres scheduler. Now there are 26 types. You can say that for a request with a hash of this type, you need a MySQL plan. Postgres doesn't have it. If it's a problem for you, come to us and we'll do it for you. The architecture optimization. It's about storage optimization, of course. So, firstly, we have alternative storage methods. In MySQL, we've had them all the time. But the most interesting of them is MyRocks. MySQL plus Rocks DB. That's an engine used in a lot of databases, and all the current internet actually runs on this engine. Cassandra uses it and others. It uses compression much better than and 4 or 5 times better than the original. So it has advanced compression, it has extremely low write amplification, and it's a very good thing that's impossible on traditional engines. It has write without reads and time to live. At the very end of our presentation, I would like to talk about distributed DBMS. As of late, there have been quite a lot of hype about such things as new SQL. I'm not talking about new SQL in particular. I'm talking about distributed DBMSs. Distributed relational databases have evoked a lot of hype. This, in the first place, Gigabyte MDB, TDB, Vitess. There are a lot of myths about such systems. First, the popularity of new SQL is growing fast. But if you read the reports, like, for instance, the one cited here from Stonebreak and Pavlo, they are quite, calm about the progress of NewSQL. They say that companies try to avoid a risk of changing the DBMS, and it's clear why. If you have a failure in the system, some report that reporting database, then it's not really a problem. But if the problem happens with the production transactional database, then you may lose a lot more. Myth number 2. This is what database vendors usually tell users they have solved all the problems. Actually, it's never exactly correct. In fact, some NewSQL databases provide for the compatibility, interoperability, some not. There are some problems with stability, tooling. Myth number 3, that everybody needs new SQL databases. I can tell you that 90% of people in this room don't need such database. Even fintech, the companies that these databases have been created for, can still use traditional databases rather than NewSQL, because traditional databases on modern hardware can do quite a lot, and modern hardware includes 100 gigabytes of memory, a lot of IOPS, and you can do a lot of things there without paying for the distribution. And they can also scale quite well for reads. You can achieve quite a lot there without migrating to a distributed database. And nevertheless, of the most requiring users who really need databases, we are planning to integrate a project from Chinese companies, Ape Cloud, called VSQL, into MyDB. This is architecture with independent storage. So it uses an LSM engine on RockDB. The data is in S3. There are HTAP capabilities and integration with DuckDB. But it's a preliminary announcement. It's all yet in the pipeline. And as to the threats, we have considered quite an exciting aspect, as I think. We discussed the aspect of performance of operating system, setups, and database features. I'm hoping that my presentation has been of interest to you. And the QR code to evaluate the presentation is in front of you. So thank you for your attention. So, question time. Please use the microphones. Thank you very much for the presentation. While you were talking about, I visited your website. You said you are part of the registry of Russian software. Your site says that you have builds for the Russian. I'm sorry, I can't really hear your question. Can they make the microphone louder? For the room. Does it come better? Yes. I wanted to ask you, I've read it on your website. Among other things, you have builds for Russian software. And I recall the story told to me by a friend. He had some bug related with some database, a build for Red OS, I think, that was only reproduced on some single version. So have you had cases of a similar nature when you were assembling your system for a Russian software product? Of course, if you can. We haven't had cases like that, but in terms of supporting Russian products, we haven't got there. Russian OS distribution. We only support Russian distributions in that they are compatible with Red Hat. So if they are, then we support Russian distributions. On the whole, thank you for the question. I would like to hear such presentations on the questions on the content of the presentation. Do you have questions on that? I just wanted to add something. No. Why don't you ask questions? I know that you always have what to add. It's just we've known each other for many years. We can discuss certain things outside. The checksum was disabled in Postgres in 2018. I want to be brought back. Well, I knew that you would come with this comment. Next question. Hello. A couple of words on MEM, I think. I understand. I'm sure you know what you talk about. All our memory is split into data banks. I'm interested in terms of configuration. Are there any configuration capabilities? In MySQL, there's an option, NUMA MDB. We just interview all the data pages, and this is the best thing you can think of. Also, there are some additional motions you can make. If you take this policy of interleaving, that it should indeed be effective, you need to do it at the very start of the database so that the cache file shouldn't create this affinity between different data in the database. Actually, we do populate, and it takes some time. And roughly speaking, we write down 128 gigabytes of zeros, so that this memory should be immediately taken from the operating system, so it shouldn't be done dynamically while it runs. Okay, next question about NUMA. Can you use NUMA for internal multi-threading? Because NUMA is about several channels, right? Well, you can take 2 instances of MySQL, fix everyone to their own NUMA node, and then shard it. So the proxy or the app level, yes, of course you can do that. It'll work until you disable sharding. So it's about very fine-tuning, right? Okay, but if I buy servers, should I buy them with NUMA? I would rather without, because in the I think you won't be able to buy a modern system without NUMA. It's the hardware vendors that walk this way. There are certain restrictions in terms of memory bus operation. So therefore, they all address NUMA as a way to grow. That's why NUMA appeared. So if you're buying a high-performance server, you buy it by the one that supports NUMA. That's just a fact of life. Thank you for your answers. Okay, You can install 2 versions of MyDB, or 2 instances of. Next question. Okay, thank you for your attention. A question. How does S3 integration impact transaction latency? Well, the impact is quite bad because S3 can provide for a station where you have a high throughput but a high latency. So what do these guys do? They implemented this kernel, this engine, to integrate it with the system. Thing is, with the commit of every transaction, FFC is done to a local S3 rather than FFD. So that's how they separated latency from durability. And the procedure of compactifying the storage is used to throw the background data without affecting the work of the processes. Any more questions? Please use the microphone once, twice, 3 times. So, up to you to select the best question. Well, actually, all the questions were good. So, you didn't like the girl, but in the Russian software registry, do you have the operating system? And the database, MyDB server, is in the Russian registry of software. As a piece of software? No, yes, as a piece of software. So which operating system do you recommend it to run on? Actually, I think Debian, perhaps. So, and Russian is, do you have any Russian? No, not yet. We support Russian distributions to the effect that some of them have binary compatibility with Red Hat. So the one from Sber supports that, and Red DOS, I think, which is Debian Live. Red DOS, yes. Well, we haven't yet got to grips with that. Of course, we do builds for DOS and Astra and Red Linux, and the guys out there are prepared to help. Did I hear you correctly that now in Q2 25, you either have already or are going to have within the next quarter Russian operating systems that will cover law 152. Yes, if somebody really needs a Russian distribution, it's very easy to do. Thank you for your question. The best question, right? Actually, all the questions were good. So my answer will be random. I like the Numa question. So, young man, please come up to us. Applause. The book from Peter. Please read. Thank you for good questions. Thank you. So, a lot of applause to our speaker for a very deep and high-quality presentation. Thank you.